Today, I'd like to conclude our discussion of the Cold War and its connection to the moon. Let's pick things back up in early 1967 with the Apollo 1 mission. It was planned to be launched on February 21st, 1967, with astronauts Gus Grissom, the second American in space, Ed White, the first American to do a spacewalk, and rookie astronaut Roger Chaffee. Unfortunately, during a test of the Apollo spacecraft on January 27th, 1967, all three astronauts died in a fire. That test wasn't considered hazardous since it was thought to be routine, without any propellant loaded onto the Saturn 1B rocket, which was the rocket that was supposed to be used for this mission. Here is a picture of an earlier test on October 18th, 1966, inside the altitude chamber at the Kennedy Space Center. I've identified the three astronauts in the picture. Something to note is that this is an earlier version of the Apollo spacecraft called Block 1. You'll notice that the pointed part of the cone-shaped spacecraft doesn't have a place to dock with the lunar module. The Block 2 Apollo spacecraft would have a different top for docking. These are pictures from the day after the fire on January 28, 1967. On the left is an image of the Apollo spacecraft looking inside. The fire consumed the entire cabin of the spacecraft. The three astronauts died from asphyxiation, that is, breathing in smoke without sufficient oxygen. The image on the right is of the outside of the Apollo 1 spacecraft. There is damage to the outside as well, since the fire was intense enough to break through the structure of the spacecraft. Let's look at some of the causes of the fire. One cause was the use of certain material inside the spacecraft. In this image, I want you to particularly consider the amount of Velcro used. Velcro was used for convenience since astronauts could stick items to the surface to prevent items from floating away when they were in space. Velcro isn't usually flammable, but what they didn't realize was that in the 100% oxygen atmosphere of the spacecraft, Velcro is flammable. Other reasons were likely rushed or shoddy workmanship. In the image above is a socket wrench that was left inside the spacecraft from the time of construction. It was only discovered in the fire investigation. It didn't cause the fire, but it did show some carelessness. The fire likely started from a spark of a frayed wire. This is a plot of the cabin pressure of the Apollo 1 spacecraft as the fire was developing inside. First note that the cabin consisted of 100% oxygen at 16.7 psi, or pounds per square inch, which is slightly higher than the typical sea level atmospheric pressure on Earth. The Earth's sea level atmosphere is typically 78% nitrogen and 21% oxygen at 14 psi. Why did they decide to go with a 100% oxygen atmosphere at a high pressure? Generally, maintaining a high pressure inside the spacecraft when the outside pressure in space is zero means making a bulkier spacecraft that has walls that are very strong. Instead, one could use 100% oxygen and then lower the pressure to about 5 psi in space, so that there is less structural stress on the spacecraft. You couldn't do this with a typical Earth sea level atmospheric composition, since if you took that composition of air and dropped the pressure to 5 psi, the astronauts would not get enough oxygen into their lungs. Another reason for avoiding nitrogen in the spacecraft atmosphere was to avoid astronauts getting the bends like scuba divers may get. Going back to the plot, you will notice that the pressure starts at about 17 psi as expected inside the Apollo 1 spacecraft, but as time progressed, the pressure climbed to about 40 psi before going down. At that point, the spacecraft had structural damage that released the pressure. We have already talked about how Gus Grissom had trouble with the hatch of his Mercury spacecraft in July of 1961. Recall that his Liberty Bell 7 spacecraft sank into the ocean during recovery since the hatch opened due to the misfiring of the hatch explosives. Due to that incident with the Liberty Bell 7 spacecraft, for the Apollo spacecraft, they settled on basically two doors. One door would open outward as shown, and the other door would need to be pushed into the spacecraft to be opened. That door was designed to push against the inside wall of the spacecraft so that it would act like a plug to prevent the cabin air from leaking. That design made it difficult to open that door during an emergency. Recall that as the fire started, the cabin pressure was increasing, so the astronauts needed to pull that door towards them to open it. Unfortunately, they simply could not open the door. For the Block 2 redesign of the Apollo spacecraft, the door was heavily redesigned as shown. The new door prevented air from leaking and opened quickly in the case of an emergency. Unfortunately, like the first Apollo mission, the first Soyuz mission ended in tragedy as well. Soyuz means Union in Russian. Soyuz 1 was launched on April 23, 1967, a few months after the Apollo 1 fire. The sole cosmonaut, Vladimir Komarov, was killed during his return to Earth when Soyuz 1 experienced trouble with its parachutes. Komarov was killed when the Soyuz spacecraft crashed into the ground. I mentioned Voskhod 1 in an earlier lecture lecture. Voskhod was the Soviet Union's transition program between Vostok and Soyuz, much like Gemini was the transition program between Mercury and Apollo in the United States. You may recall that this mission was launched on October 12, 1964, and was the first multi-person mission with 3 people on board. They didn't have much room to work with, so they didn't use spacesuits. They relied on the Voskhod capsule for their pressurized air. This mission went smoothly, but the practice of not wearing spacesuits would come back to end in tragedy. Soyuz 11 was a mission flown by the Soviet Union in June of 1971. The crew consisted of Gregory Dobrovolsky, Vladislav Volkov, and Viktor Patsayev. This mission became the first and only mission to the first space station, Salyut 1. After successfully docking with the Salyut 1 space station and having conducted their mission, the crew began to head back home on June 29, 1971. Their 24-day mission ended in tragedy when recovery personnel found the 3 cosmonauts dead inside the spacecraft. There was no visible damage to the spacecraft, so it wasn't like the Soyuz 1 case where the parachutes failed. It was found that there was a leak in the spacecraft during their mission, yet while in space, the cabin pressure had dropped to 0. The 3 cosmonauts died as a result. They are to this day the only humans to have died in space. I have a few quotes from Gene Kranz, a NASA flight director at the time of the Apollo program, that I think are especially poignant for all of these tragedies in space. After the Apollo 1 fire, Kranz gave a speech to other flight controllers at NASA where he said, "From this day forward, flight control will be known by 2 words, tough and competent. Tough means we are forever accountable for what we do or what we fail to do. We will never again compromise our responsibilities. Every time we walk into mission control, we will know what we stand for. Competent means we will never take anything for granted. We will never be found short in our knowledge and in our skills. Mission control will be perfect. When you leave this meeting today, you will go to your office and the first thing you will do there is to write tough and competent on your blackboards. It will never be erased. Each day when you enter the room, these words will remind you of the price paid by Grissom, White, and Chaffee. These words are the price of admission to the ranks of mission control." Earlier in that same speech, Kranz said the following, "We were too gung-ho about the schedule and we locked out all of the problems we saw each day in our work. Every element of the program was in trouble, and so were we. The simulators were not working, mission control was behind in virtually every area, and the flight and test procedures changed daily. Nothing we did had any shelf life. Not one of us stood up and said, 'Damn it, stop.' I think these are essential words as the United States, other countries, and commercial companies look to the future. NASA, for example, plans on putting people on the moon by 2024, which I like to point out is only 62 months away from today. To anyone who is willing to listen, the history of human space exploration is very clear on the price of rushing." I'd like to get to Apollo 11, but before that, I want to make sure to cover a few topics. First, I want to point out that the Soviet Union was also working on a Saturn V type rocket called the N1. Development of the N1 rocket started about 4 years after work on the Saturn V. The N1 launched 4 times, but each launch failed. If you visited or plan to visit the National Air and Space Museum in Washington, D.C., you will see models of the Saturn V and N1 rockets next to each other as shown in the image. Unlike the Saturn V, which had 5 large F1 engines for its first stage, the first stage of the N1 had 30 smaller engines. Developing the large F1 engines were not easy and took considerable time. So having a later development start, the Soviet Union did not have time to develop F1 type engines. They chose to use many smaller engines to produce the necessary thrust. It was very difficult to get all 30 engines to do what they were supposed to do at the same time. So the N1 wasn't successful. On the left is an N1 rocket being assembled, and on the right is a spy satellite picture of the N1 rocket from the United States Air Force dated September 19, 1968. Another thing I want to mention before I get to Apollo 11 is that there were different methods that were proposed for getting people to the moon. The first was direct ascent, as shown on the left. As the name suggests, this method called for a rocket that would launch from the Earth and go directly to the moon. To do direct ascent, a very large rocket was needed, since it had to carry a large lander that was capable of launching from the moon's surface to come back to the Earth. A simple model of such a lander is shown in the middle. Being very massive, that lander would require a gigantic rocket to carry it directly to the moon. NASA was initially considering building such a gigantic rocket called Nova. This diagram from 1962 shows the Saturn I, Saturn V, and the Nova rockets for comparison. Notice that the Nova rocket is even bigger than the Saturn V rocket. While the Saturn V's first stage had 5 F1 engines, the Nova would have had 8 F1 engines. NASA realized that building such a gigantic rocket was impractical due to the cost and complexity, so they elected to go with a method called Earth Orbit Rendezvous as the method of choice. In this method, a series of small rockets such as the Saturn I would launch segments of a moon-bound spacecraft into Earth orbit. Those segments would be assembled in Earth orbit, and then the completed spacecraft would go to the moon. This is why this method is called Earth Orbit Rendezvous. Earth Orbit Rendezvous was the preferred method for a while. People like John D. Byrd advocated for the method. On the left is a picture of Byrd, and on the right is a diagram that Byrd drew outlining the Earth Orbit Rendezvous method. You may notice that various segments are marked with 1C1, which means one Saturn I launch would take that component into orbit. He proposed 10 Saturn I launches would be needed to make the moon-bound spacecraft. Note that they would need to launch 5 Saturn I rockets just to get the necessary propellants into Earth orbit. This diagram has the heading, "To the moon with C1s or bust." The method ultimately used for Apollo was Lunar Orbit Rendezvous. Lunar Orbit Rendezvous was first proposed by Yuri Kondratyuk in 1916. He is pictured on the right. Kondratyuk was born in 1897 in Poltava, which was in the former Russian Empire, but is now in modern-day Ukraine. I've included a postage stamp from Ukraine that honors him and has a small diagram of the Lunar Orbit Rendezvous method. Yuri Kondratyuk was an identity that he adopted because he feared for his safety since he was sought by the government. Tom Dolan, who knew of Kondratyuk's method, was the first person inside NASA to propose this method. Almost no one listened to Dolan. The person who did listen and who became the proponent of Lunar Orbit Rendezvous within NASA was John C. Hubble. He is pictured on the right. He became so frustrated at one point that he stepped outside the usual management chain within NASA and sent a letter directly to the NASA Associate Administrator, Robert Siemens. The letter partly read, "Why is Nova, with its preponderous size, simply just accepted? And why is a much less grandiose scheme involving rendezvous ostracized or just put on the defensive? I fully realize that contacting you in this manner is somewhat unorthodox." NASA eventually did listen and adopted Lunar Orbit Rendezvous as the method of getting humans to the moon. Okay, now let's get to Apollo 11. I have already made a case that the space race was effectively over by early 1966, largely due to the death of Sergei Korolev, but also because the United States had started to develop more sophisticated space technologies than the Soviet Union. Yet, there was one last race to the moon in July of 1969. The race was to see which country could land on the moon and bring back lunar material to the Earth before the other. The Soviet Union launched a robotic sample return mission called Luna 15 to compete with the American Apollo 11 mission. Luna 15 launched on July 13, 1969, 3 days before Apollo 11. However, while Apollo 11 successfully landed on the surface of the moon on July 20th, 1969, Luna 15 crashed onto the moon on July 21st, 1969. I've shown the landing site of Apollo 11 with an orange dot and the crash site of Luna 15 with a blue dot. I'd like for you to now take a look at the few minutes prior to the Apollo 11 landing. You will see the video that was filmed by the Apollo 11 crew on the left and the newer image of the locations of the moon shown on the right. The video wasn't broadcasted live to Earth since the communication was limited. So if you were someone who was watching the television coverage, you would have mainly heard the audio transmissions along with graphics to help viewers understand what was happening.
Manual attitude control is good.
Roger, copy.
Altitude 4200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet. Copy. Alarm. 1201. 1201.
Roger, 1201 alarm. We're go, same type, we're go.
2,000 feet. 2,000 feet. Into the ag, 47 degrees.
Roger.
37 degrees.
Eagle looking great, you're go.
Altitude 1,600. 1,400 feet, still looking very good.
Roger, 1202, we copy it.
35 degrees. 35 degrees. 750, coming down to 23. 700 feet, 21 down. 33 degrees. 100 feet, down at 19. 540 feet, down at 30. Down at 15. At 400 feet, down at 9. 8 forward. 1050 feet, down at 4. 33.5 down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Put up. On 1.5 down. 70. Got the shadow out there. 50 down at 2.5. 19 forward. Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward. Good. 120 feet. 100 feet. 3.5 down. 9 forward. 5%. 185. 75 feet. Car's looking good. Down a half. 6 forward.
60 seconds.
Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drifting to the right a little. 20. Down a half.
30 seconds.
Forward. Just. Good. Okay. Contact light. Okay, engine stop. ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. Port 13 is in.
We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Thank you.
You're looking good here.
Okay, we're going to be busy for a minute.
This video shows the moments when Neil Armstrong first stepped onto the surface of the moon.
You got a good picture, huh?
There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail.
Okay, we can verify the position the opening I ought to have on the camera.
Stand by. Okay, Neil, we can see you coming down the ladder now.
Neil, we can see you coming. Okay, I just checked getting back up to that first step. It's not even collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera. Okay. At the foot of the ladder, the lamb footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the lamb now. That's one small step for man, one giant leap for mankind. As the surface is fine and powdery, I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. I only go in small fraction of an inch, maybe an eighth of an inch, but I can see the footprints of my boots and the treads and the fine sandy particles. Neil, this is Houston. We're copying. There seems to be no difficulty in moving around as we suspected. It's even perhaps easier than the simulations of 16G that we performed in various simulations on the ground. Absolutely no trouble to walk around. The decent engine did not leave a crater of any size. It has about 1 foot clearance on the ground. We're essentially on a very level place here. I can see some evidence of rays emanating from the descent engine, but very insignificant amount.
We have already discussed a number of astronauts and cosmonauts who passed away during this period in time. This picture shows a plaque that Apollo 15 astronauts left on the moon to remember those who had died up to that point. They also left a small model of an astronaut next to the plaque. It's hard to see the names in the plaque, so I've listed the names. Charles Bassett and Elliot See died when their airplane crashed before their Gemini 9 mission. Pavel Bayaev passed away after successfully having flown on Voskhod 2. Roger Chaffee, Gus Grissom, and Ed White died in the Apollo 1 fire. Gregory Dobrovsky, Viktor Patsayev, and Vladislav Volkov died during Soyuz 11. Theodore Freeman died in an airplane crash prior to going into space. Yuri Gagarin died in an airplane crash. He was the first person to go to space. Edward Givens died in a car crash before flying in space. Vladimir Komarov died during Soyuz 1. Clifton Williams also died in an airplane crash prior to going into space. While we remember astronauts and cosmonauts, we should also remember those who supported missions to the moon and passed away while doing their jobs. I've listed some of them here, but there are many more. Morris Carter died on January 28, 1960 after Morris was hit by a truck while watering down the Saturn rocket pad. Felipe Bengues died on April 27, 1964 due to an explosion while supporting the Apollo program. Oscar Simmons died on July 2, 1964 after falling from the 26th level of the Vehicle Assembly Building. Marian Anderson died on May 4, 1965 when Marian was struck by a 12-foot wooden form that fell 457 feet inside the vehicle assembly building. Albert Tribe died on August 5, 1965 after being struck by lightning while pouring concrete at Launchpad 39B. V.S. Evans was killed by a descending elevator at Launchpad 37 while working on the Saturn 1B rocket on March 16, 1966. The end of the space race is typically marked by the Apollo-Soyuz test project, which was a joint mission between the Soviet Union and the United States. It was launched on July 15, 1975 and became the first multinational crewed mission in space history. There were 3 American astronauts who flew on the Apollo spacecraft and 2 Soviet cosmonauts who flew on the Soyuz spacecraft. The crew consisted of prominent figures from the space race. Tom Stafford was the commander of the Apollo 10 mission, which served as a rehearsal for the Apollo 11 mission. Deke Slayton was one of the original Mercury 7, but as you probably recall, was grounded due to a heart condition. Slayton finally got a chance to go to space during this mission. Alexei Leonov was the first person to do a spacewalk. Alexei Leonov passed away on October 11, 2019. Here's a tweet from Michael Collins, who flew on Apollo 11. The tweet states, "Alexei Leonov was not only the first spacewalker, but quite a character too. Once he greeted me by lifting me a meter off the ground. He was a talented artist and a spokesperson for the Russian space program, and a wonderful human being. Godspeed, Alexei." If you visited or plan on visiting the National Air and Space Museum in Washington, D.C., there is a model of the docked Apollo-Soyuz mission. On the left is the Apollo spacecraft connected to the Soyuz spacecraft on the right. Here's a video clip of the moment in the mission when the Apollo spacecraft and the Soyuz spacecraft docked and the 2 crews greeted each other in space.
That's good. Palomino, Mila, Alexei.
Soyuz docking system is ready. Good job. Let's stay there. Look at that. Coming, Tom.
I am approaching Soyuz.
Tom, please don't forget about your engine.
Less than 5 meters distance.
3 meters.
3 meters.
3 meters.
1 meter. Contact. Capture. Tell Professor Bushuyev it was a soft docking.
Well done, Tom. It was a good show. They are looking forward now to shaking hands with you in both Soyuz.
All right, on a show. Открываю you, Luke 3. Okay, the camera. Aha! Passenger. Got it? Okay, it'll stay open. Go ahead. Go ahead, Tom. Alexei. Just a moment. Okay, turn on the camera. Hit the remote. Okay. Here. Camera. Glad to see you. Here. Passenger, Alexei.
I was trying to find a fitting picture to end the series of lectures on the Cold War and the space race. I like this picture quite a lot. Take a moment to guess who the woman and the man are in the foreground. Also try to guess who is the person in the framed picture in the background. A hint is that this picture was taken in June 1970. Also, another hint is that all 3 people are very important figures in space history. The woman is Valentina Tereshkova, the first woman in space. She is putting a pin on Neil Armstrong, the first person to walk on the moon. The person in the framed picture is Yuri Gagarin, the first person in space.